Okay, let's start working with logarithmic expressions. So we're going to do something called expanding. And this is similar to what we do with exponential, okay? The difference is that we only have 3 rules to use, okay? And the idea here is there's only one log. For each variable. And there are no exponents. That's it. Those are our rules. So let's take some basic examples. Again, I wouldn't worry so much about the... I lost my train of thought. Forget what I said. It'll come back to me. Okay, so let's say, for example, that we have log base 6 of m times n times p. Okay, so what we're doing is we're expanding because we're taking one log and we're making it into multiple logs. And this is going to have 3 logs in it because we have 3 letters. And everything is multiplication. So when we do multiplication, it turns into addition. So we have log base 6 of m plus log base 6 of n plus log base 6 of p. So this side would be considered the condensed form. So we'll condense eventually. This is condensed form. And this side would be considered the expanded form. So notice we have no exponents. Okay. And we have only one log for each variable. Okay, let's take another example. We're just going to do a bunch of these. Notice the base is not really important here, okay? Whether it's a base 6 or base 10 or a base 7, makes no difference. Just make sure that when you write it in your expanded form, you're including the same base. Okay? Let's say that we have log base, let's just leave it as base 10, of the cube root of m to the 4th n. Okay, so I immediately went into something that was a little bit uglier, right? So the first thing that you're going to want to do is you're going to want to simplify what's in here. And a cube root, change it into a power. Every time that you see a radical, change it into a power. So this can become log of m to the 4th n to the 1/3. And then I would encourage you to distribute this exponent. So it's up to you. You don't have to. There are 2 different ways that you can do it, but I would distribute the exponent. Kind of depends on which you're more comfortable with. Exponents or logs? I forgot my m. So this becomes m to the 4/3 times n to the 1/3. Well, now we can separate this. We're going to use the product rule. Product rule says this is log of m to the 4/3 plus log of n to the 1/3. Okay, so we use the product rule, and now we're going to use the power rule. We're going to take these, and we're going to move them out to the front. That's how we get rid of the exponents. So we get 4/3 log of m plus 1/3 log of n. Okay, so notice what we did here. What we did is we kind of simplified this exponential expression first, and then once that was simplified in its simplest form, we broke up the logarithmic expression, okay? Let's take another one. Let's say that we have log base 2 of m squared n over p. And if you have log base 2 of m squared n over p, then we're going to break this up in pieces. This is log base m squared plus log, sorry, not base m squared, base 2 of m squared plus log base 2 of n. And then the p is in the denominator, we're dividing, so quotient rule says we subtract. So log base 2 of p. And now the only thing that we have to do is move the exponent out to the front, which gives us 2 log base 2 of m. And then the rest just stays the same because they don't have any exponents. So this minus comes from the fact that that p is in a denominator. Okay, let's take another example. Let's say that we have log base 3 of m to the 4th n over p squared q. Okay, so we're going to do this in 2 steps, okay? Let's use the quotient rule first. Let's subtract. So that means that we have log base 3 of m to the 4th n minus log base 3 of p squared q. Now we can separate each of these. So this is multiplication, so that means that it's going to turn into addition when we separate it. Now we're subtracting this whole thing, so now we need parentheses. And there's multiplication in there, so that also gets split using addition. Notice, be careful to put in your bases. Okay, so now we can distribute this minus. So the minus gets distributed, which gives us log base 3 m to the 4th plus log base 3 of n. And then notice what's happening here. The p squared is in a denominator, and it gets a minus sign in front of it because we're dividing, right? And we know through the quotient rule that we get subtract. Now the q is also in a denominator, which means we're also going to be subtracting it because that minus distributes. So we can actually skip the first 2 steps and go right to the third. If we have something in the denominator, it gets a minus. Okay, if our variable's in the denominator, it gets a minus before the log. And this is why, because a minus is eventually going to be distributed. So we could jump right to here. We don't have to do these intermediary steps, okay? Which makes our life much easier. We can make this much shorter. So our final answer here is 4 log base 3 of m plus, there is no exponent for the n, so plus log base 3 of n, minus the 2 comes out to the front, so 2 log base 3 of p, minus log base 3 of q. And that's our final answer there. So that's kind of a huge thing when we use these properties because it's going to save us a lot of time. So let's write that down. If a variable is in the numerator, the log is positive. And if a variable is in the denominator, the log is negative. This is going to save us so much time. Ready? We can skip directly to this step if we want. You don't have to. Let's do another one. And we're going to use this rule to help us. Let's use log. Let's use ln. Ln of m squared r cubed over q squared n to the fourth, and we'll square this. So you have two options. You can take this 2, move it out to the front, and sort of leave it out front up until the end. So you can make this 2 times the ln of m squared r cubed over q squared n to the fourth, and then expand that expression, and at the very end distribute that 2. Or you can distribute the 2 here, which is, I prefer doing it that way. It's a personal preference because then I don't forget about that 2. So if we do it that way, we have ln, and now this becomes m to the fourth, r to the sixth, q to the fourth, n to the eighth. Okay, so we got rid of that 2 here, and we don't have to worry that we're going to forget about it later. And now what that means is we can break this apart, and we don't have to do it in lots of steps. We know that the log before m to the fourth and r to the sixth is going to be positive, and the log before, I'm sorry, I should switch this. And the log before q to the fourth and n to the eighth is going to be negative because those are in the denominator. So let's just do that. This can automatically go to the ln of m to the fourth plus ln r to the sixth minus ln q to the fourth minus ln n to the eighth. So anything that was in the denominator gets a minus sign. Anything that was in the numerator gets a plus sign. Hang on, I lost my pen. Okay, I think my pen is almost out of battery, and that's why. Okay, so now we just need to bring the exponents out to the front. So you're going to simplify this expression first, okay, the exponential expression first, and then it's really simple just to expand our logarithmic expression. Let's take one more. Let's do log. I'm not going to use a base here. Of the square root of m times n. So I'm putting a little tail on the square root so that it's clear it's not part of it. N is not under the square root. N cubed. P to the fifth over n times q squared over p squared. Okay, so now we got this nice, really complicated expression, but it's not that bad. So we're gonna go and we're gonna do this. We're gonna simplify this expression first. It's not that hard to simplify. We actually don't have a lot of steps here. And then we're gonna just expand. So the expansion is really fast because we know this. Now again, this is not the only way to expand. You can expand in steps. It kind of depends on what you're more comfortable with. If you're more comfortable with the logarithmic properties, then you're going to expand and simplify it as you go. Maybe this one we'll do in both ways, okay? But if you're more comfortable with exponents, then you're going to simplify this exponential expression first. So what we can do is we can actually, we're going to do two things at once. We're going to distribute this square, and we're also going to take care of the square root of m because we don't want any radicals, okay? So we're going to do two things simultaneously. So what that means is this is going to become log. We're going to make this m to the 1/2 n cubed p to the 5th. Now we know that this is multiplication, so these are actually just going to combine with one another, and we could write it all together. So we get a q to the 4th over n, and then a p squared. Okay, so when we distribute this square, we get q to the 4th over p squared. That's this last part here, q to the 4th over p squared. Now we can simplify that just by combining. We have m to the 1/2. And this is n cubed over n, which is just n squared. P to the 5th over p squared, we subtract the exponents and we just get p cubed. And then we have q to the 4th. Okay, I probably didn't need such a giant parenthesis here. So we could just take that out and make it a little bit smaller. And now we're just going to break this up. So we have log of m to the 1/2 plus log n squared plus log p cubed plus log q to the 4th. And our final step is just to move all of the exponents out to the front. If we had made this a p cubed and this became a p to the 6th, then we would have had a p to the -1, and that would have made it a minus sign, okay? So you're simplifying your exponential expression first, and then you're separating your logs. Now let's say that we didn't want to simplify the exponential expression first. Let's say that we wanted to do expansion first, okay? My suggestion would still be to change your radicals, okay? So, second method. So I'm going to automatically make the square root of m and m to the 1/2 here. So don't get confused when you see it. That's the square root of m, okay? So if we separate this, if we expand first, you'll just see the difference. You can do whichever one you're more comfortable with. You get the log of m to the 1/2 n cubed p to the 5th over n plus the log of q squared over p squared. Okay, there was multiplication here, so we can expand it by making it into addition. Now we can do each of these separately. So what that means is we have log of m to the 1/2 plus log of n cubed plus log of p to the 5th minus log of n. Now we have plus this, and we could take this 2 and we can move it out to the front. So I'm going to do that in 2 separate steps. So now we have 2 times the log of q squared p. Okay. You can combine some of these steps. I'm not combining steps just so that you can follow along a little bit more easily. So now I'll move these exponents out to the front. So all of this, the exponents just go out to the front, and then plus 2, and we need a parentheses here. Log of q squared minus log of p, because this whole log is being multiplied by 2, okay? So now we're going to make this a 4. So the reason why we make it a 4 is we're going to distribute, we're going to do 2 things at once. We're going to multiply, we're going to bring this exponent out to the front, and then we're going to distribute the 2. Okay? So 2 things at a time. Again, you can absolutely combine steps here. So this becomes a 4 log q, because when we move this 2 out to the front, it's a 2, and then when we distribute it, 2 times 2 is 4. And then minus 2 log p. And then at the very end, this is where you combine like terms. So this is the same thing as doing n cubed over n is n squared. Notice we have a 3 log n minus a log n. That gives us the 2 log n that was up here. And now here we have a p to the 5th over p, which gives over p squared. We're almost done. P to the 5th over p squared, which gave us a p cubed. Here we have a 5 log p minus the 2 log p, which gives us the 3 log p. That's over here, okay? The plus 3 log p. So we wind up with the same answer. And this one, you just don't need to know your, you don't have to know your exponential properties as well as you need to know your logarithmic properties. So it's kind of up to you which one you prefer. Okay, so we just combined like terms here. Because if you remember, one of the rules is that you only have one log for each variable. Now before we do condensing, I'm going to give you one more example to try. This one I'm not going to work out with you, okay? All I'm going to do is I'm going to give you the answer. So this is a nice complicated one. You're not going to like me very much. So this is a 4th root. If you can do this one, you absolutely understand how to do expansion of logarithmic expressions. So this whole thing is being squared. And we're going to keep this 4th root going. Then we have times p squared over q to the -3. And we're going to raise this to the -3 power. So this whole thing is under the fourth root. And this is a negative 3. This is also a negative 3. Let me rewrite that 3 because it doesn't really look like a 3. It looks like a 3 on my paper. It just doesn't look like a 3 on the screen. Okay, so we have the fourth root of m to the fifth n cubed times the sixth root of p times q r over p to the second power times p squared over q to the negative 3 raised to the negative 3 power. And all I'm going to do is I'm going to give you the answer. So I want you to take the time to work this out and keep working it out until you get the correct answer. Okay? So pause at this point, work it out. What you get at the end is 5/2 log m plus 3/2 log n plus 1/2 log r minus 23 over 12. So you're going to have some fractions in there. Log p minus 7/4 log q. Okay, and that's your final answer. So keep working through it until you get that.